Hi, welcome to Unit 8, Lesson 1. In Unit 8, we're going to be looking at all different kinds of graphs or data representations. So in mathematics, when we gather data, we have to have a way to represent that data in a way that makes sense to the people that are looking at it. So normally there's been some sort of study or experiment or survey, something where you're generating data that you then want other people to be able to clearly interpret. And so we can do that with several different kinds of graphs. The first kind of graph that we're going to look at is a bar graph. And so you'll see in your notes here a couple of examples of bar graphs. They're exactly what they sound like. They use bars to represent categories. So remember, that's kind of their purpose. Different kinds of graphs have different purposes. The purpose of a bar graph is to be able to compare categories. So you can look at a bar graph and very quickly distinguish which ones have the lowest values, the highest values. It's just easy to make those distinctions on a bar graph. So if you're trying to set up your data so that the person who is looking at it can easily compare categories, then a bar graph is a great way to do that. So if we look at this first bar graph, it says daily production of TV sets. And so we can see that on the x-axis, we have the days. So we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And then on the y-axis, we have number of TV sets. And we can see that it goes up to 450. And then we have a bar for each day to show how many TVs were produced on that day. We know from the title right here, the title is always important because it tells you exactly what it is that you're looking at. And in this case, we're looking at the production of TV sets. Now, right away, I would say when you're looking at a bar graph, there are a couple of things that you should focus on. So look at your x-axis label, and then look at your y-axis label as well. So looking at the title and then the x-axis label and the y-axis label, you're able to tell what kind of information the graph is telling you. So that's always the first step. Don't start trying to answer questions or to analyze any of the data until you've really wrapped your mind around what is this particular graph telling me. Once you've done that, then before you start answering any questions, I would suggest that you go to each bar on the bar graph and label the value of that bar. That way you'll be able to answer any questions that you're being asked about those categories. So if I look at Monday, I can see that Monday is at 300. Tuesday goes up to 400. Wednesday goes to 200. Thursday is at 250. Friday is at 100. Saturday is at 350. And then Sunday is at 150. And then another piece of information that I always like to have when I'm looking at a bar graph is to go ahead and get the total number of pieces of data that are represented in the bar graph. So to get my total, I would simply add all those up. So 300 plus 400 is 700. 700 plus 200 is 900. 900 plus 250 would be 1,150. And then 1,150 plus 100 would be 1,250. And then plus 350 would be 1,600. And then plus 150 would be 1,750. So always just go through and total up your data, and that'll just give you a good idea of exactly what you're looking at. So again, all we did here was add up the total for each one of the bars on our bar graph. Just list those out, and we can add them up here. So have all zeros there, and then 5 plus 5 is 10, plus 5 is 15. And then 1 plus 3 is 4, plus 4 is 8, plus 2 is 10, plus 2 is 12, plus 1 is 13, plus 3 is 16, plus 1 is 17. So our total here is 1,750. And that's always helpful information to have. So we could say that the total number of TVs produced during that week was 1,750. Now, what we're going to do is determine which of these statements are true. So the first one says fewer than 30% of the TVs are produced on Thursday and Friday. So if I were to add together Thursday plus Friday, so we already have the bars labeled. So Thursday was 250 plus Friday was 100. So 250 plus 100 is 350. And then it said 30% of the TV. So 30% of that total. So 30% of 1,750. So to find 30% of 1,750, remember to take 30%, turn it into a decimal by moving that decimal 2 to the left. So that becomes 0.3 or 0.30. 3 times 5 is 15. 3 times 7 is 21, plus 1 is 22. 3 times 1 is 3, plus 2 is 5. And then we need to account for the decimal. We have one decimal or one digit after the decimal in the problem. So one digit after the decimal in our answer. Oops, so that was 525. So 30% of 1,750 we just found to be 525. And this said, fewer than 30% of TVs are produced on Thursday and Friday. Well, Thursday and Friday brought a total of 350, and then 30% of 1,750 was 525. And 350 is definitely fewer than or less than 525. So this is a true statement. Look at the next one. Less than 1/10 of the TVs are produced on Wednesday. So on Wednesday, we have a total of 200. So we need to see what 1/10 of 1,750. So if we divide 1,750 by 10, or just shift the decimal 1 to the left, that gives us 175. And this says less than 1/10 of the TVs are produced on Wednesday. So we look and see, well, on Wednesday, 200 TVs were produced. We need to see, is that less than 1/10? Well, 1/10 is 175. 200 is not less than 175. So this one is not true. Okay, last one. Exactly 20% of the TVs are produced on Saturday. So on Saturday, if we look at our chart, our bar graph, we saw that 350 TVs are produced on Saturday. So now we need to see what 20% of that total is. So 20% of 1,750. So let's do 1,750. And again, if we take 20% and move that decimal 2 to the left, that becomes 0.2 or 2/10. 2 times 0 is 0. 2 times 5 is 10. 2 times 7 is 14, plus 1 is 15. 2 times 1 is 2, plus 1 is 3. One digit after the decimal in the problem. So one digit after the decimal in our answer, and that's 350. So 20% of 1,750. And we just calculated that and found it to be 350. And this said exactly 20% of the TVs are produced on Saturday. On Saturday, 350 TVs are produced, and that matches exactly what we got for 20% of 1,750. So this statement is also true. So the first statement was true, and the third statement was true. Okay, let's look at the second bar graph. So this bar graph is called a double bar graph because you can see what we have here. In our title, it says minutes of homework. And then on the x-axis, we have teachers. You can see we have Mr. Smith, Miss Williams, Miss Jones, and Miss Brown. And then on the y-axis, we have number of minutes. But then we have a pink bar and a purple bar for each teacher. So we can look over here and see that the pink is Wednesday and the purple is Thursday. So we have Wednesday, Thursday, Wednesday, Thursday, Wednesday, Thursday, Wednesday, Thursday. So what we're seeing here is on each of those days, the number of minutes of homework that each of those teachers assigned. So we'll do just like we did before and label the bars with the total that they're showing. So Miss Smith on Wednesday was at 14 minutes. Miss Smith on Thursday was at 16 minutes. Miss Williams on Wednesday was at 14 minutes. And on Thursday, she was at 10 minutes. Miss Jones on Wednesday was at 16 minutes. And on Thursday, Miss Jones was at 20 minutes. And then on Wednesday, Miss Brown was at 6 minutes. And on Thursday, Miss Brown was at 18 minutes. Now, a couple of things that we might want to do here. We could add up all of those to get a total number of minutes. And we could add up all the Wednesdays and get a Wednesday total. We could add up all the Thursdays and get a Thursday total. We could add up Wednesday and Thursday for each teacher and get their total for those days. So there are lots of pieces of information that we could pull from what we have right here. So again, we're going to look at these statements and see which statements are true. So the first one says the combined minutes of homework on Wednesday is 50% of the combined minutes of homework on Thursday. Let's go ahead and get a Wednesday and Thursday total. So Wednesday, that's all the pink bars. We have 14 plus 14 plus 16 plus 6. So 4 plus 4 is 8, plus 6 is 14, plus 6 is 20. And 2 plus 1 is 3, plus 1 is 4, plus 1 is 5. So our Wednesday total is 50. And on Thursday, we have 16 plus 10 plus 20 plus 18. 6 plus 8 is 14. 1 plus 1 is 2, plus 1 is 3, plus 2 is 5, plus 1 is 6. So our Thursday total is 64 minutes. And this says the combined minutes of homework on Wednesday is 50% of the combined minutes of homework on Thursday. So combined minutes on Wednesday was 50 minutes, and combined minutes on Thursday was 64. So what we're saying here is 50 equal to 50% of 64? Well, 50% of something means half. And so we're saying 50 equals half of 64. Well, half of 64 is 32. That is not true. 50 is not half of 64. So that statement is false. Okay, the next one. The minutes of homework in Miss Jones' class on Thursday was double the minutes of homework in Miss Williams' class on Thursday. So we're going to get Miss Jones on Thursday. And on Thursday, Miss Jones, that's the purple bar, Miss Jones was at 20. And Miss Williams on Thursday was at 10. And this says the minutes of homework in Miss Jones' class, which is 20, was double the minutes of homework in Miss Williams' class, which was 10. And that's true. 20 is double 10. So 20 is double 10. Okay, last statement. The combined Wednesday and Thursday homework minutes for Miss Smith are equal to the combined Wednesday and Thursday homework minutes for Miss Brown. So let's look. So if we look at Miss Smith, and this said combined Wednesday and Thursday. So if I go to Miss Smith, that is 14 plus 16, which equals 30. And then I want to look at Miss Brown and get her combined Wednesday and Thursday. So for Miss Brown, that was 6 plus 18, which is 24. And it says these were equal. Well, 30 does not equal 24. So this statement is not true. And that is it for Unit 8, Lesson 1, bar graphs. So again, bar graphs are just a special kind of data representation that is specifically used to allow us to compare categories. A couple of helpful reminders. When you're looking at a bar graph, I would always start by looking at the title, the x-axis label, and the y-axis label, just to have a really good idea of what information you're being given on the graph. And then go ahead and label each bar. You're probably going to need all of that information in order to analyze the graph anyway. So go ahead and take the time to label each bar before you try to answer any questions or analyze any data from the graph. If you have any questions or want to look at some additional bar graphs, let me know and we can do that. If you're ready to have the spell check open, I'm happy to do that for you. Thanks and have a fantastic day.